Okay. Good morning, everyone. Am I audible? Okay. Okay. Thank you for your replies. Good morning. Okay, then we shall start. Okay. So before starting, today, just now, before 5-10 minutes, I have shared with you the PDF files for disinfection and also the clariflocculator. Okay, I have shared these two PDF files in your this official our group. CR, please distribute this. Okay, clariflocculator and disinfection. Please share with all your classmates. So yesterday we have discussed about disinfection. So you know what is disinfection and also the minor methods. I have told you to write 3 methods, so you can write it down today. Okay, I have shared with you. So we were at I think we were at types of chlorination. If I am not wrong, we were here yesterday. We were about to discuss this one as the last topic. Okay. So types of chlorination. There are 7 types of chlorination you see here. 7 points are written. Your plain chlorination, pre-chlorination, post-chlorination, double chlorination, breakpoint chlorination, superchlorination, and dechlorination. Okay, so we have to know what each of these definitions are. So number one is your plain chlorination. So plain chlorination is basically uh, when no other treatments are given to the water. Okay, like we have studied about screening, then we have studied about plain sedimentation, then coagulation, okay, filtration. So all these things we have studied. Okay, so when all these treatments these are not given to the water and only chlorine is added to the water directly in the raw water directly your chlorine is added. So that process is known as your plain chlorination. And this helps this plain chlorination. It is usually done in like when water it should be given to your army troops and all, as I already mentioned. So there it cannot all the treatments it cannot be given because there is shortage of time and all. So only chlorination is done. So plain chlorination directly without giving any other treatments, only chlorine is added to the water, and that also kills 99% of the bacteria. Okay, so also we have it's written here. You see, um, this term is used to indicate the only the chlorine treatment and no other treatment has been given to the raw water. Okay, so under plain chlorination, therefore, raw water is fed into the distribution system after giving chlorine treatment only. So, before supplying it to the distribution system, the water is treated with chlorine. Okay, so this helps in removing bacteria, organic matter, color from the raw water. Okay, obviously that will remove bacteria. Okay, so, this technique, your plain chlorination, it is usually not used for much like more turbid waters or more colored water. it is not used for those kinds of water. Okay, since only this plain only chlorine is added, so the water it is from beforehand only the water it is relatively clearer. Okay, it has less turbidity and all, so it can be used for treating the waters. Those are relatively clearer from before. Okay, and so the turbidity is with less than 20 to 30 milligram. So that water is having 20 to 30 milligram per liter of turbidity, less than of that turbidity. So it is used to those kinds of water. Okay, and last line you see the used quantity of chlorine required for plain chlorination is about 0.5 milligram per liter or more. Okay, so what is the dose of chlorine required for plain sediment? Plain chlorination? It is 0.5 milligram per liter or more. Okay, so next is your pre-chlorination. So pre-chlorination it is what, when chlorine it is added before your filtration process or before your sedimentation coagulation process. Okay, so pre-chlorination it is you see here it's written already. It is Pre-chlorination is the process of applying. From the name itself, it is pre. Okay, that means before. So pre-chlorination is the process of applying chlorine to the water before filtration, or rather before sedimentation coagulation. So before filtration or before your sedimentation aided with coagulation process, your when chlorine is added to the water, it is known as your pre-chlorination. Okay, then it helps in improving the coagulation and reduces the loads on the filters. Okay, then the chlorine dose, you see the chlorine dose should be such that about 0.1 to 0.5 milligram per liter of residual chlorine comes to the filter plant. Okay, residual chlorine means residue. It's a residue, the chlorine that is left behind. Okay, that is your residual chlorine. Okay, so the normal doses required are as high as 5 to 10 milligram per liter. Okay, so the dose is 5 to 10 milligram per liter for your pre-chlorination. And after your pre-chlorination, it is always followed by what? Post-chlorination. So pre-chlorination is done, then your again post chlorination is also, it should also be done. Okay, for for your final safety. Okay, so what is post chlorination, you see? So from the name itself, post, that means at the end. Okay, so post chlorination it is applied at the end of your all the treatment processes. Okay, so you see here post chlorination, or sometimes simply called chlorination, is the normal standard process of applying chlorine in the end when all other treatments have been completed. So when you have given all other treatments like everything, screening to disinfection, okay, then softening, you have done the softening process, everything when you complete. So after that, when you apply the chlorine to the water, so that is just before distributing the water to the public. Okay, so that is known as your post chlorination. Okay, you see here the dosage of chlorine should be as to leave a residual chlorine of about 0.12 milligram per liter. So it should be the dose, it should be like that, so that it leaves a residue chlorine. Okay, it leaves a chlorine residue of about what? 0.1 to 0.2 milligram per liter. Okay, so after a contact period of about 20 minutes. Okay, so this is all about your post chlorination. Next, let us see. Next is your double chlorination. Okay, so what is double chlorination? Actually, your pre-chlorination and your post-chlorination together, it is known as your double chlorination. Okay, so you see here the term double chlorination is used to indicate that the water has been chlorinated twice. Obviously, from the name itself, it is double. That means the it is the water is chlorinated twice. So the pre-chlorination and the post-chlorination are generally used and in double chlorination. So when both the processes are done together, so it is known as your double chlorination. Okay. So post-chlorination, however, is generally always used, while the pre-chlorination is also used when the waters are highly turbid and contaminated. As I already said, when you do pre-chlorination, yeah, then that pre-chlorination it should be or it must be followed by post-chlorination also to ensure what? To ensure safety of the water. Okay. So since the double chlorination uses pre-chlorination prior to the normal post-chlorination, its advantages are the same as those of pre-chlorination. So, since your pre-chlorination is used first, then your post-chlorination is done. So, for double chlorination, the advantages of double chlorination is same as your what it has been for pre-chlorination. Okay, so then okay, next is your breakpoint chlorination. So, what is breakpoint chlorination? You see, okay. So, breakpoint chlorination actually it gives you the idea of how much chlorine you have added to the water. Okay, of how much it gives an idea of how much amount of chlorine you have added to the water, and also if you know if you have added excess of chlorine, okay, excess of chlorine, then what will happen? The some of the chlorine it will appear as your free residual chlorine. Okay, the name is your free residual chlorine. So it's a residue of the chlorine. Okay, so it's written here. Breakpoint chlorination is a term which gives us the idea about of the extent of chlorine added to the water. Okay, in fact, it represents that much of dose of chlorination beyond which any further addition of chlorine will equally appear as free residual chlorine. Here, so when you add you keep on going adding your chlorine, so what will happen at some point those chlorine it will appear as free residual chlorine, and that is indicated by what? Breakpoint chlorination. And so to understand this, a graph is given here. You see here a graph is already presented here. So what this graph says is that, let's see that one. Okay, you from here you see, from here you see, if chlorine is slowly added to water and the residual is tested, it will be found that the residual will go on increasing with the addition of chlorine. Okay, so how to test residual chlorine? It is done by one test known as DPD test. Okay, you see here a name, DPD test. Okay, so when you go on adding chlorine to the water, so what will happen? And if you do residual chlorine test, so you will find that the residual chlorine it will go on increasing with the addition of your chlorine. Okay, so but some of the chlorine, okay, it is used. Obviously, we have added chlorine to kill the bacteria, isn't it? We are adding chlorine so that it kills the bacteria. So obviously, some chlorine will be consumed by the bacteria. Okay, some chlorine it will be consumed, for the killing of bacteria, and that amount of residual chlorine it will slightly be less. Okay, what amount you have added, so some amount will be it will appear less because that less amount some amount it is consumed by the bacteria for its killing. Okay, so what this graph says is that, let us see. Which, okay. So this curve from A to B, you are seeing. Okay, so A to B is what you are adding chlorine, and the residual it is going on increasing. Okay, and the residual chlorine it is going on increasing from A to B. Okay, so now from B to C, the curve has fallen down. So why it has fallen down, let us see. Okay, so what it is written here, if the addition of chlorine is continued beyond the point B. Okay, so the organic matter present in water starts getting oxidized. Okay, and therefore the residual chlorine content suddenly falls down. Okay, so from A to B, you are adding chlorine, and the residual chlorine it is also going on increasing as per you are adding chlorine. Okay, but at a certain point B, what happens that the chlorine the if you continue giving chlorine to the water, so that there is organic matter present in the water. Yes, so that organic matter, that means the bacteria. Okay, so that those bacteria, those organic matter, it starts getting oxidized because of those chlorine. Okay, so what happens, the residual chlorine content it falls down, suddenly it falls down. Okay, and that part is known is shown by the curve BC. Okay, then again the point C, okay, it is the point beyond which if you continue adding chlorine, if you continue to add chlorine, then it will appear as your free chlorine. Okay, and nothing of the chlorine it will be utilized because the organic matter it has already been oxidized. Okay, so this point C from which the chlorine again the chlorine content it appears as free chlorine and it is going increasing. So this point C it is known as your breakpoint. Okay, and this is known as your breakpoint chlorination. Okay, so the point C is the point beyond which any further addition of chlorine will appear equally as free chlorine. That means whatever chlorine, your free chlorine you are adding, so it will appear as that chlorine only. Okay, no more chlorine will be used by the bacteria because the bacteria has already been killed now. Okay, so the curve it is now going on increasing, and this point C it is known as your breakpoint chlorination. Okay, so what is written here? This point C is called the breakpoint, as any chlorine that is added to water beyond this point breaks through the water and totally appears as residual chlorine. The addition of chlorine beyond breakpoint is called breakpoint chlorination. Okay, so the dose you see, the dose here, it is a general practice to add chlorine beyond breakpoint, and thus to ensure a residual of 0.2 to 0.3 milligram per liter of free chlorine. So the doses of chlorine for your breakpoint chlorination is your such that it leaves a residual of 0.2 to 0.3 milligram per liter. Okay. So next is your superchlorination. Okay, from the name itself, you can make an idea that here excess of chlorine is used, isn't it? You see here, superchlorination is a term which indicates the addition of excessive amount of chlorine. Okay, and what is the dosage? It is 5 to 15 milligram per liter to the water. So this may be required in some special cases of highly polluted waters. Okay, or during epidemics of waterborne diseases. So actually it is used very rarely because so much of chlorine is not good for anything. What why when it is used for some special cases where you can say the water is very highly polluted, or also during when so there are some waterborne diseases. So at that time only you use or you do superchlorination. Okay, so again the doses is 5 to 15 is there. Okay, let huge quantity of chlorine which is added in superchlorination is to restore beyond the breakpoint. Okay, so okay, this much only you write down. Okay, up to here, if you write down, then it's fine. Hmm. Okay, next, last you see, last is your dechlorination. So dechlorination. So from the name, also from again from here, also you can make it an idea that after adding chlorine, okay, and after adding chlorine to the water, whatever chlorination you have done, plain chlorination, pre-chlorination, post-chlorination, okay, whatever chlorination you have done, and the work of the chlorine has done its work. Okay, it has killed the bacteria, but now you have to remove that chlorine from the water. You cannot supply the water with the chlorine itself that remains chlorine. Okay, the water it will remain chlorine because you have to remove that chlorine from the water so that you can supply the water to the public. Okay, and for that you have to do dechlorination. The last step is your dechlorination. Okay, so it is a removal of chlorine. Okay, you see here the dechlorination means the removing the chlorine from water. Okay, this is generally required when superchlorination has been practiced. So when superchlorination you have done, so because superchlorination you have added excessive amount of chlorine to the water. Okay, so for that you need to remove that chlorine from the water. Okay, so the dechlorination process may either be carried out to such an extent that sufficient chlorine 0.1 to 0.2 milligram do remains in water after dechlorination. So this is a dose, okay, 0.1 to 0.2. And what are the common dechlorinating agents? The names you have to remember: sulfur dioxide gas, activated carbon, sodium thiosulfate, sodium metabisulfate. Okay, so these names you remember here. So this is all about your this types of chlorination. Okay, so here with this we have ended our chlorination and disinfection part. Okay, so disinfection part is finished. So next is your I guess water softening is there. So all these treatments I will not go in very fast because uh, for your this semester I think you should know in short. Okay, every treatment processes you should know what is this, what is that. Okay, you should know at least the terms you should know. Okay, so I will not go in that brief. So first you see here what is water softening. Okay, so what is water softening? As we have already discussed before, that when the water is hard, okay, we have already discussed that when the carbonates and bicarbonates of calcium and magnesium are present in water, okay, so those term it is known as your temporary hardness or permanent hardness. We have already discussed. Yes, so the we cannot consume the water which is hard. Okay, so we have to make it soft. We have to remove the hardness from the water. Okay, so that reduction or the removal of hardness from the water, it is known as your water softening. Clear? So you see the first line from here. The reduction or removal of hardness from water is known as water softening. Clear? So next, okay, one more line you can note it down. It may also be recalled that we have already actually previously studied that the permissible hardness for public supplies. Okay, what is the permissible limit for hardness? It is your 75 to 115 milligram per liter. Okay, so we will see what are the methods. Okay, what are the methods for removing temporary hardness? There are two types of hardness. Yes, one is your temporary hardness and the other one is your permanent hardness. So how to remove the temporary hardness? One is your boiling. Okay, number one is your boiling. So you this boiling you write it down in your copy. It's not that long. So this one you can write it down. Then the chemical equations also you write down. Okay. Then after boiling, one more is your addition of lime. Okay, these two processes, addition of lime and boiling, by doing these two processes, you can remove the temporary hardness from the water. Okay, and also you also write down this number 2 also. Okay, addition of lime, you write down these chemical equations, and then up to here you write down. Okay, then for removing your permanent hardness, again there are methods. Okay, there are again
Ma'am,
methods
can you
for
show the boiling definition?
boiling definition. You want to see
Yes,
definition?
ma'am.
Actually, not definition. It is like your just the process is written what it is present. Okay, you can see here while boiling, what gas is evolved. Okay, what gases goes up. You see here it is written calcium carbonate being only slightly soluble in water, so it remains in water as calcium bicarbonate. Okay, so calcium carbonate, okay, being only slightly soluble in water, so calcium carbonate is not that much soluble in water. It will exist in water as your calcium bicarbonate because it easily dissolves in natural water containing carbon dioxide. Okay, so all these chemical equations are written chemical bicarbonate. So this equation is only explained here. Okay, it is explained here. So this one you study by yourself. Okay? This one softening. Okay, after this class, I'm sharing you this one. Okay, no need to take screenshot.
Okay, ma'am.
It will be better if I provide. Okay, so you can see and write in your copy. After the class, I will share. Okay.
Okay, ma'am.
Okay. Okay, so again, there are some methods for removing your permanent hardness. So temporary hardness, you remember that by boiling the water and by adding lime to the water, you can remove temporary hardness. Okay, and for removing permanent hardness, it is not that much easy. So some long procedures are there. Okay, so number one is your lime soda process. Okay, number one is your lime soda process. Number two is your base exchange process, which is also known as your zeolite process. Okay, it is also known as your zeolite process. And number three is your demineralization process. Here, demineralization process, zeolite process, and lime soda process. By these three processes, you can remove your permanent hardness. Okay, so no need to go in that much details for these processes because it only contains, you see, these chemical equations you see here. Okay, these all chemical equations are here, you see, but uh, you should know, you have to know that in lime soda process what is done, you should know that one. Okay, so this is a recarbonation plant. Everything is given here. I have clicked the photos, but no need to write all. Okay, no need to write all. From here, the lime soda process and zeolite process difference is important. Okay, difference between your lime soda process and zeolite process is important. You can choose any 5 points. Okay, 5 points from the table. 5 points from this is a big table you can see. So you can choose any 5 or 6 points and you can write it down. Okay, the zeolite process and lime soda process difference. So we are about to end our your chapter 1. Okay, this is this miscellaneous treatments are there. 2, 3 this one points are there. This one I will cover up in the next class nicely. Okay, so today let us end it here. Okay, rule number 69. Then 51. Dineshwar.
51 present, ma'am.
Okay, 51 present. Then 52.
Ma'am, 51 is present, ma'am.
Okay, 51. I'm giving.
Thank you, ma'am.
Okay. Then 52, 53, 54.
Ma'am, 53 present.
Okay. 55, 56, 57.
7 present, ma'am.
57. 58, 59, 60.
60 present.
60 present. Okay.
Yes, ma'am.
61.
Present, ma'am.
Okay. 62.
Yes, ma'am.
Okay. 63.
Yes.
Okay. 60.
63.
Okay. 65, 66.
66, ma'am. Yes, ma'am.
Raju is present. Oh, sorry. Pankaj Shah. Pankaj Shah is present. Okay.
Yes, ma'am.
Okay. Then 67.
Jen, ma'am.
Okay. 68.
68.
Okay. 69. 70.
70 present, ma'am.
70 present. Okay. 71.
Present.
Okay. 72.
Present, ma'am.
Okay. 73.
Present, ma'am.
Okay. 74.
Present, ma'am.
Okay. 75. 76.
Present, ma'am.
Okay. 77.